Welcome to our deep dive into the fascinating world of heat. In this chapter, we'll explore what heat really is, how it moves, and why it's so important in our daily lives. From the warmth of the sun to the way your coffee cools down, heat is everywhere. We'll break down the science behind heat, look at how it's measured, and discover the many ways it affects the world around us. Whether you're curious about why metal feels cold or how a refrigerator works, this journey will answer your questions and spark your curiosity about the invisible energy that shapes our environment. Heat is a form of energy that flows from a hotter object to a cooler one. It's not a substance, but rather the transfer of energy due to a temperature difference. We measure heat in units called joules, though calories are sometimes used as well. Imagine touching a warm mug. What you feel is heat moving from the mug to your hand. This transfer continues until both objects reach the same temperature. Understanding heat is crucial for everything from cooking to engineering, as it helps us control and utilize energy efficiently in countless applications. Temperature is a measure of how hot or cold something is, but scientifically it tells us about the average kinetic energy of particles in a substance. The higher the temperature, the faster the particles move. Temperature is measured in degrees Celsius, degrees C, Fahrenheit, degrees F, or Kelvin K. While heat and temperature are related, they are not the same. Temperature is a property, while heat is energy in motion. Understanding temperature helps us make sense of weather, cooking, and even how machines operate. Induction is the process where heat moves through a material without the material itself moving. Think of a metal spoon in a hot pot. Heat travels from the pot to the spoon and eventually to your hand. This happens because particles in the hotter part of the spoon vibrate more and transfer energy to neighboring particles. Metals are especially good at conduction, which is why they feel cold to the touch. They quickly transfer heat away from your skin. Convection is another way heat travels, but this time it involves the movement of fluids, liquids, or gases. When a fluid is heated, it becomes less dense and rises, while cooler, denser fluid sinks. This creates a cycle called a convection current. You see convection in action when boiling water. Hot water rises to the top, cools, and then sinks again. Convection is key in weather patterns, ocean currents, and even heating your home. Radiation is the transfer of heat through electromagnetic waves without needing any medium. The warmth you feel from the sun is a perfect example of radiation. Unlike conduction and convection, radiation can travel through the vacuum of space. All objects emit some thermal radiation, but hotter objects emit more. This process is crucial for life on Earth, as it's how we receive energy from the sun and how objects cool down by emitting infrared radiation. Specific heat capacity is a property that tells us how much heat is needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Different materials require different amounts of heat to change temperature. The formula is Q equals mc delta, where Q is heat, m is mass, c is specific heat, and delta is the temperature change. Water, for example, has a high specific heat, which is why it takes a long time to heat up or cool down. Latent heat is the energy absorbed or released by a substance during a phase change, like melting or boiling, without changing its temperature. For example, when ice melts to water, it absorbs heat but stays at 0 degrees C until all the ice is gone. This hidden energy is crucial in natural processes, such as the water cycle, and in practical applications like refrigeration. Understanding latent heat helps explain why sweating cools us down, and why steam burns are so dangerous. Thermal expansion is the tendency of materials to expand when heated and contract when cooled. This happens because particles move faster and push each other further apart as temperature rises. You can see thermal expansion in everyday life. Railway tracks have gaps to allow for expansion, and bridges use expansion joints. If not accounted for, thermal expansion can cause structures to warp or crack, making it a critical consideration in engineering and construction. Thermometer measures temperature by using materials that expand or change properties with heat. The most common type is the liquid in glass thermometer, where mercury or alcohol expands as it gets warmer, rising up a calibrated tube. Digital thermometers use electronic sensors to detect temperature changes. Thermometers are essential tools in science, medicine, and daily life, helping us monitor everything from fevers to weather conditions. It's easy to confuse heat and temperature, but they are different concepts. Heat is the energy transferred between objects due to a temperature difference, while temperature measures how hot or cold an object is. For example, a bathtub of warm water contains more heat than a cup of boiling water, even though the cup is hotter. Understanding this distinction is key to mastering the science of heat and energy. Thermal equilibrium occurs when two objects in contact reach the same temperature and no longer exchange heat. Imagine placing a hot spoon in a cup of cold water. Over time, the spoon cools down and the water warms up until both are at the same temperature. At this point, they are in thermal equilibrium. This concept is fundamental in thermodynamics and helps explain how energy is distributed in systems. Heat transfer isn't just a scientific concept, it's something we experience every day. Cooking food, ironing clothes, and even feeling the warmth of sunlight are all examples of heat transfer. Engineers use heat transfer principles to design efficient stoves, refrigerators, and even buildings. Understanding how heat moves helps us stay comfortable, save energy, and create better technology for our homes and workplaces. Heat engine is a device that converts heat energy into mechanical work. It operates by taking in heat from a high-temperature source, using part of that energy to do work, and then releasing the remaining heat to a cooler area. Cars, power plants, and even steam engines use this principle. The efficiency of a heat engine depends on the temperature difference between the heat source and the sink. The greater the difference, the more work can be done. Refrigerator works by removing heat from its interior and releasing it outside. It uses a fluid called a refrigerant, which absorbs heat as it evaporates inside the fridge and releases it as it condenses outside. This process is powered by a compressor and follows the principles of heat transfer and phase change. Refrigerators keep our food fresh by maintaining a cool, stable environment, making them essential in modern life. Matter changes from one state to another. solid, liquid, or gas, through phase changes like melting, freezing, boiling, and condensation. These changes involve energy usually in the form of latent heat, but the temperature stays constant during the transition. Understanding phase changes helps explain natural phenomena like the water cycle and is crucial in industries that rely on freezing, boiling, or condensation processes. Insulation slows down the transfer of heat, helping keep things warm or cool. Materials like wool, foam, and fiberglass trap air, which is a poor conductor of heat. Insulation is used in buildings to reduce energy costs, in clothing to keep us warm, and even in thermos flasks to keep drinks hot or cold. By understanding insulation, we can design more energy-efficient homes and products. Thermal conductivity is a property that measures how well a material conducts heat. Metals like copper and aluminum have high thermal conductivity, making them good for pots and pans. Materials like wood or plastic have low conductivity and are used as insulators. Knowing the thermal conductivity of materials helps engineers choose the right materials for specific applications, from cookware to building insulation. Several factors influence how quickly heat is transferred: the temperature difference between objects, the surface area in contact, the type of material, and the thickness of the material. For example, a thin metal sheet heats up faster than a thick one, and a large surface area allows more heat to flow. Understanding these factors helps us design better heating and cooling systems and improve energy efficiency in everyday life. Solar water heater uses the sun's energy to heat water, reducing the need for electricity or gas. It consists of solar collectors that absorb sunlight and transfer the heat to water stored in a tank. This system is eco-friendly and cost-effective, making it popular in many homes around the world. Solar water heaters are a great example of using natural heat transfer for practical benefits. Thermal radiation is the emission of energy as electromagnetic waves, mainly in the infrared spectrum. All objects emit some thermal radiation, but hotter objects emit more. This is why you can feel the heat from a campfire even if you're not touching it. Thermal radiation plays a key role in heating, cooling, and even in the greenhouse effect that warms our planet. Cooking is a practical example of heat transfer in action. Whether you're boiling, frying, or baking, heat moves from the stove or oven into your food, changing its temperature and texture. Different cooking methods use conduction, convection, or radiation to achieve delicious results. Understanding how heat works in cooking helps you control the process and create perfect meals every time. Heat transfer drives weather patterns around the globe. The sun heats the earth unevenly, causing air and water to move in convection currents. These movements create wind, clouds, and storms. Meteorologists study heat transfer to predict weather and understand climate change. The next time you feel a breeze or see a thunderstorm, remember that heat is at the heart of it all. Industries rely on heat transfer for processes like metalworking, chemical production, and power generation. Controlling heat efficiently can save energy, reduce costs, and improve product quality. Engineers use advanced materials and technologies to manage heat, from high-temperature furnaces to cooling systems in electronics. Mastering heat transfer is essential for innovation and sustainability in modern industry. Our bodies constantly produce and lose heat to maintain a stable temperature. We generate heat through metabolism and lose it through conduction, convection, radiation, and evaporation. Sweating helps cool us down while shivering generates more heat. Understanding how our bodies manage heat is crucial for health, especially in extreme environments or during exercise. Architects and engineers use heat transfer principles to design comfortable, energy-efficient buildings. Insulation, window placement, and ventilation all affect how heat moves in and out. Smart building design can reduce heating and cooling costs, improve comfort, and lower environmental impact. By understanding heat, we can create spaces that are both pleasant and sustainable. Clothing helps us manage heat by trapping air and reducing heat loss. In cold weather, we wear layers to keep warm, while in hot weather, light and breathable fabrics help us stay cool. The materials and design of clothing are based on principles of heat transfer, making them essential for comfort and survival in different climates. Vehicles use heat in many ways, from engines that convert fuel into motion to air conditioning systems that keep us comfortable. Managing heat is crucial for safety and efficiency. Engineers design cooling systems for engines and use insulation to protect passengers from extreme temperatures. Understanding heat transfer helps make transportation safer and more reliable. Electronic devices generate heat as they operate. If not managed properly, this heat can damage components and reduce performance. Engineers use heat sinks, fans, and special materials to dissipate heat and keep devices running smoothly. Effective heat management is essential for everything from smartphones to supercomputers. Heat is a fundamental force that shapes our world, from the smallest particles to the largest systems. By understanding how heat is transferred, measured, and controlled, we unlock the secrets to everything from cooking and comfort to technology and industry. As we've seen, heat is not just a scientific concept, it's a vital part of our everyday lives. Keep exploring and you'll discover even more ways that heat powers our world and drives innovation.